Hello everyone and welcome back to this next lecture. So in the previous lecture, I had showed how to test your TMDS-Dock28069 microcontroller kit. Now, of course, that video was meant for those who had the TMDS-Dock kit. In this video, I'm going to show you how you can test your LAUNCHXL-F28069 kit in almost exactly the same manner. So if you look at the video, I have right in front of me, or at least in the middle of the video, the LAUNCHXL kit. Now, one part of the USB cable has been connected to my laptop and the second part has been left unconnected. So I'm going to start by connecting this to my kit. So as you can see, when you start it, I'm going to zoom in a little here. And when you start it, you will see some glowing LEDs. It's a smaller kit and therefore I need to adjust it. So you will see a glowing LED. Now, if you already watched the video from the TMDS dock, you would have seen that there is no code running on the TMDS dock in the beginning. However, this LAUNCHXL-F28069 kit has a code which is already running the minute you power it up. So the minute I connected the USB cable, there is a code already in the boot ROM which loads up and starts running. And that's the reason why you see this LED glowing, and you will also notice a small flashing LED at the edge, which is like a blue or a purple LED. It's very faint, but this is because of a control code which is running. Now, to test this kit, of course, I would not assume that you're going to just take this as the kit to be working, because remember, we haven't done anything yet. And it's important that not only should be able to power up the kit the way we have done, but we should also be able to communicate to it, and we should also be able to run some sample project code. And that's what we are going to do for now. So with this, I'm going to go back to my Code Composer Studio. So in this Code Composer Studio, you would notice right now a blank screen. If you're starting it for the first time, you might also see a get started window. You can just close that, right? Now, to be able to run a control code on our microcontroller kit, we need to check out an example project. Now, if you would recollect, when we installed C2000ware application and we were browsing through the files, I showed you where you can find examples. Now, I'm going to go and show you exactly which example we are going to run on our LAUNCHXL-F28069 kit. So let me go to my file browser. So now I'm in the C drive, wherever it is that you have installed Texas Instruments and you have installed C2000ware. As I said, it is recommended that you install Code Composer Studio and C2000ware in a same parent directory just to keep them together. So in my case, it is in this directory TI, and within that C2000ware. Now, among all these directories, we should go to the directory device support, okay? Because this is support for each and every device which is provided by Texas Instruments. And in that you will see this directory F28006X. X merely stands for the fact that the last digit can be anything, 1 to 9. And in our case, it is 9. Of course, you should also remember that the TMS320 is assumed. All of them are TMS320. So let's open this. And within this, you will see a directory examples. So let's click on it. Within that, you will see two directories, C28 and CLA. CLA stands for Control Law Accelerator, which is a slightly advanced concept, and we won't discuss that in this course. We will look at the basic examples, which is C28. So within this, you will see a lot of examples, and as this course progresses, we will actually start exploring different examples. But for now, all we want to do is test our microcontroller kit. And for that, I'm going to pick out a very simple example, which we have to go all the way down here, and you will see it here, timed LED blink. This project will flash an LED on the microcontroller kit at regular intervals. And this is a great way to know, number one, that you are able to compile project and download it on your microcontroller. And number two, you are able to execute the control code on the microcontroller. This also guarantees that the communication between your host computer and your microcontroller is fully functional. So what I'm going to do is I'm going to import these projects, and I'm going to show you how to do that. If you go to Code Composer Studio, you will see a number of menu options at the top. You will see one called Project. So let's click on Project, and you will see several options here. As we progress later on, I'll show you how to create a new CCS project. CCS stands for Code Composer Studio. Now, what we want to do is we want to come down here and click on this link, Import CCS Projects, which simply means we are going to import an existing Code Composer Studio project, which is what we want to do. So I'm going to click on it, and it's going to ask you for a search directory. All you have to do is mention the directory where all those example files are, and it will import everything. So that's what you can do. Let's go browse on it. Again, let me start from the beginning. So let me go to my C drive. I'll go to the TI folder, go to whichever folder you've installed C2000, C2000ware, device support, and within this look for your family, which is F28069. And here we can click on examples, or you can actually just click on F28069, because once you click on the folder, it will start searching for examples within that. So that's all we need. So let me click on this, and as you can see, it has populated everything. So we need to look for our timed example. So if you keep coming down, and here you will see this example underscore 208X 2086X LED blink, and that is in the folder timed LED blink, which I just showed you. So let us click on this checkbox. You can import multiple projects, and in the later sections I will show you how that is done, because after all, not only will we be building projects, we'll also be comparing it with example projects. So this is when it's actually quite useful to have multiple projects open on your workspace. But for now, we just need one. So let me click on this. Okay, I think we need the Project Explorer. Okay, so for some reason the Project Explorer was not open. As you can see, all you have to do is go to View and click on Project Explorer, right? Now for some reason I probably closed everything down. That is why the case. If that is the case with you, all you have to do is go and click on View and click on Project Explorer, and that will show you the projects which are currently open. So let us click on this, and as you can see, once it becomes bold, it is active. Now if you click on this little arrow here, you will see you can open it up, and there are a number of files here. Now the main file is this file example underscore 2806X LED blink. We can open it and you can go through it, but right now we're not going to do that. We just want to test our microcontroller kit. So the first thing we need to do, we need to establish our communication between the host computer and the microcontroller. So for that, go over, take your mouse to the name of the project, right? I'm right on that name. Then right click and go all the way down to properties. So this lists out all the properties of the project, right? Now, as we go on, I will show you several other properties and how you should change them. For now, we don't really care that much. So let me just go, and here if you see, this is the actual base project settings. And here you will see the device. We must select our device and we have to attempt to connect to it. So here if you see, there is a family which is C2000, then there is the variant and the core. Now, as of now, while making this meeting, first while choosing the variant, we must go all the way down and choose F2806X Piccolo, because this entire F2806X is the Piccolo series, including many others also. It's not just the F206X, others are also Piccolo, but for us it is this family that matters. So let's click on it. Now here, I'm making this video in August 2024. At this time, the LAUNCHXL-F28069 is not in the drop down list. That is, this is not one of the specialized processors or other kits which is there. The experimenter kit, which is the TMDS dock, is listed, and if you watched the previous video, you saw that you might have seen that I selected it. Of course, if you didn't watch it, doesn't matter, you haven't lost anything. But here, because our LAUNCHXL-F28069 is not present, we must go and select just the basic microcontroller, that is TMS320F28069. So we'll click on this, and now we must choose our communication. So if you see here, this is the connection. We will click on the connection, and you see there are a number of options here. Now, depending on what you have available with you, if you have only the LAUNCHXL-F28069 and the USB cable, because these are the only two things that come with the box, and as I said, that's all you need. If you have only those two, then you must select one of these, that is the Texas Instruments XDS100 series. Now this XDS100 series is a number of USB emulator family. This is a communication protocol. This is XDS100 is the name of a chip. Now at this time, this supports, the protocol that is supported is 100v2, that is version 2, XDS100 version 2. Now, if you are watching this video significantly in the future, then there might also be 100 version 3 supported, because USB version 3 has now come out and slowly hardware is being supported for USB version 3. At this time, it is not being supported, so I am going to click on version 2. Now, once this is done, you must click verify. This will verify whether you can connect to your microcontroller kit and you are able to communicate. So if I go up and scroll, it will give you a lot of things because it is doing a test communication. It is sending data to the microcontroller, it is asking data from the microcontroller, and based on this exchange, it is giving us a little report. Now, the details, there may be a few things, for example, some things it cannot do, some things it cannot read, some things it cannot write. There are things like this, and you will see them. You don't have to go into the details. All you have to do is this last line here. The JTAG integrity scan test has succeeded. If you see this line, that means you are able to successfully communicate with your microcontroller kit. Now, I'll give you an example of when this may not happen. As I said, as of this time, version 3 is not supported. So let's go and click on version 3, and I'm going to click on verify again. And now you see there is an error. The reason is it is saying that one of the FTDI driver functions used during the connect returned bad status or an error. It simply means that this hardware protocol is not supported. So always remember, if you are using something special, check out the data sheet and check out what protocol you are using and specifically use that. If you are watching this video, then my suggestion is use version 2. Or you can, even if you have an old computer and you do not have USB version 2, USB version 1 will also be supported because the hardware supports version 2, and in most cases it will also be backward compatible. So in this case, I'm choosing version 1, I'm clicking on verify again, and you see once again you get the same result, that is integrity scan test has succeeded. So even with version 1, it does connect successfully to the microcontroller kit. Anyway, I am going to go back to version 2 because version 2 is supported, and it's always best to use the latest version because that is usually faster and less buggy. So I'm going to again click on verify just in case, and everything is okay. So once we are done with this, you don't bother changing any of this, right? These are like compiler versions and things like that. Right now, we are not going into any of those details. So all you must do is you must save it, because we have made these changes, right? We have changed the variant, we have changed the microprocessor chip, and we have also changed, or rather we didn't really change, but you would have changed the connection protocol. So click on apply and close to save your changes, right? So now we have succeeded in communicating with the microcontroller kit, and now we are ready to compile our code and download it to the microcontroller. So for that, what we have to do is we need to do a compile. This compilation is called a build. Now, if you go to project you will see a number of options with respect to build. You see this entire section. There is build project, build all, build configuration, several. Now, when you build a project, it will build all the C files that are in the project. It may also build some assembly files which are in the project, and so on and so forth. And it will create a target output directory. Now, as you're working on this, as you continue working on projects, you will find yourself compiling over and over again each time you make changes to your source code. So therefore, get into the habit of performing a clean before you build. A clean will delete any previously compiled files and create a fresh output directory. This guarantees that any previous bugs or any other mistakes that may have made that resulted in badly compiled files will first be deleted before the newly compiled files are created. So I'm going to click on clean. Now it will say clean all projects, and you can do that, doesn't really matter. Even if there are multiple projects, cleaning is never a bad thing. Now it will say start a build immediately, which you also want to do. You can build the entire workspace, which I would not recommend, because if you have several projects, you're just building all of them all the time, which is really a waste. You only need to build selected projects, the one that you're working on. Since there is only one, this is automatically selected. As we go on further, and when I show you there'll be multiple projects, you can actually select which ones you want to compile. So I'm going to click on clean, and this will start the compilation project. So as you can see, it is building the project. And let me minimize this and show you. You will see here, this is the compilation output. Now again, a lot of this is very much hardware specific, and I wouldn't expect you to learn all this. We don't have to go into this much detail of hardware, but it is basically compiling each and every C file which is there in this project, and it is finally producing a hardware specific .out file, which is like a assembly output file. Now you may see some warnings, right? It's saying it cannot resolve something. If you're building product code, that is final product code, it is recommended that you even resolve some of these warnings, right? For now, since we are only learning microcontroller programming, I wouldn't go into so much detail. Any warnings we can just ignore. It doesn't really matter that much. Warnings are to be resolved definitely when you are going in for final product code. Alright, so with this, we are now ready to download our compiled code to the microcontroller. So at this point, I'm going to bring the microcontroller back into the video. So you will now see the microcontroller in the video. It is exactly in the same state we left it, because this is still running the control code which is actually in the boot ROM. So whenever you power it up, that control code will automatically start working. But now, since we've already communicated with our microcontroller, we can now start downloading the control code. Now there's two ways to, of course, there is one way to do this, but there are two approaches. You can click on this little bug icon, and if you go out here and hover on this, it will say debug example underscore 20866 LED blink. Debug means you're going to download this control code, and you are also going to be able to execute it. Now, if you like to use actual menu options rather than these kind of icons, then you can go to run and you can click on debug. It's exactly the same thing. It will now start the download process. So I'm going to click on debug. Now it simply says this because what happens is we've been changing it again and again. So I'm just going to say OK. Just make sure that it is 100 version 2, because that is the latest version that this microcontroller kit can support. So this will now start the download process. It is now downloading the control code to the microcontroller kit, right? And when you see this final result, right? When you see all this along with all these menu options, this means that the control code has been downloaded onto your microcontroller kit. And if you look at your microcontroller kit in the video, you will notice that the red LED has turned off. There was a red LED which was flashing before. Now it is turned off. Why? Because we have downloaded fresh code onto the microcontroller. Now, if you want to run this control code, it is still not running yet. We have only downloaded it. To run the control code, again, you can click on this run button, which is resume. Again, if you're not too fond of clicking on little buttons, you can click on the run menu option and go down and click on resume. So I'm going to click on this, and now you will see that there is a flashing LED on the microcontroller kit. Right? So this flashing LED is the result of a timer. The microcontroller, we have, at least the example, has programmed a timer, and with that timer it is now flashing an LED, right? And as we go on, we'll go into more details later. We'll actually examine the control code, and we'll even write similar control code in the next few lectures, or rather in the next section. But most importantly, if you have arrived at this state, that means you are able to compile your project successfully, you are able to download your project onto your microcontroller, and you are able to execute your control code. This is the result of what we have done. And if that is the case, your microcontroller is now ready for programming. You are now ready to continue with the rest of this course. If you have not arrived at this result, then something is seriously wrong. Please stop, post in the Q&A forum, and until you resolve this issue, do not continue. You must get this result if you want to be able to program the microcontroller. There can be any number of reasons. We must debug only by finding out what the problem is with the project and other communication issues. So, again, if you have any other doubts about what we have done, please do post in the Q&A forum, and I'll be happy to help you out. But if you've reached this stage, all is well and you're ready to go. Now, just in case before we finish, I would like to add a little bit of a tidbit. That is, if I click on this, if you want to stop, then you can either click on this red button, which is like a stop button, or again, you can go to run and you can go down and click on terminate. This will terminate the code. But this takes us back to our project page. But if you observe the microcontroller kit, you will see that the red LED is still flashing. And the reason is because the control code is still working. Even though we have actually exited the debug mode, the control code is still working. All we have done is we have broken our connection. If I click on this debug button again, it is going to again download the same compile code. We have not recompiled it. The same compile code back into the microcontroller, and now you will see that the red LED stops flashing. And this is because we have now again overwritten the control code with a fresh control code, but this control code is not working. So the microcontroller again is in an idle state. It is in an idle state waiting for fresh commands. So again, with this, I'm going to end this lecture. Let me just click on the terminate button finally, and we go back to our project page. Again, anything didn't work, any other issues, any other doubts, please do post in the Q&A forum and I'll help you out. Otherwise, I will see you in the next lecture. Thank you so much for listening, and see you soon. Goodbye for now.